Okay, in this tutorial we are going to go through two-step equations. This is a situation where we literally have an equation that contains two or more operations. So for example, we can write the equation 2y plus 3 is equal to 6. In order to solve this equation, we would have to subtract 3 from both sides. We'd have 2y is equal to 3, and then we'd need to divide both sides by 2. If you notice, I just use inverse operations as well as inverse operations because there's technically a multiplication symbol there. So our final answer for this particular problem would be y is equal to 3 halves. That's besides the point. Let's try a couple of different problems. Let's move our way down here. In this process, we are going to use inverse operations, and as we remember with inverse operations, they undo each operation that we have been working with. I want you to keep in mind when we do this, we are going to play with the concept of Pemdas. So, parentheses, exponents, multiplication and division, addition and subtraction. With Pemdas, we are going to be doing these in reverse order. Normally we do parentheses first, then we look at our exponents, then we do whatever multiplication and division, and then addition and subtraction. But in this case, we are going to be doing this backwards. So we're going to start with addition and subtraction. We are then going to go to multiplication and division. Then you would be looking at exponents, and then parentheses. So I guess this is asympdep or something like that. I'm not even going to worry about it. But using this concept of working backwards, let's tackle our first problem. We have 6x plus 1 is equal to 25. According to Pemdas, we should be doing parentheses, exponents, multiplication, division, addition, and subtraction, but we're going to be doing it backwards. So we need to focus first on our addition and subtraction. In this particular equation, we have a plus 1 being added to 6x. So to undo this, we're going to do the inverse of operation of subtracting 1 from both sides. This is where it's really, really helpful for us to have that whole concept of this equal sign. We want to make sure we're doing things the same on both sides. If you notice, I just subtracted 1 on both sides. So I end up with 6x. Those 1's add to 0 is equal to 25 minus 1 is 24. So I have 6x is equal to 24. Now, next step, we are going to do this multiplication and division step. I have something being multiplied. We have 6 times x, and now we're going to be dividing that. We're going to divide by 6. I'm going to show you the fraction form of this. So we have 6x, 6 over 6, that ends up being 1 over 1, so we just have our simply x. And we have 24 divided by 6 equals 4. So for this particular equation, x is equal to 4, and we can check our work by saying 6 times 4 plus 1 is equal to 25. Let's see if that works. Now we're doing the actual order of operations. We're going to do our multiplication and division first. 6 times 4 is 24, and then we're going to add 1 is equal to 25. 24 plus 1, yep, that equals 25 every time. So 25 is equal to 25. Check. That ended up working out for us. That's awesome. Now let's practice another problem. We have 4x minus 5 is equal to negative 33. Once again, we're going to be working backwards. So working backwards, we're going to look for addition and subtraction. So our addition and subtraction that I see is I see a minus 5. So if we are subtracting 5, the opposite of that, the inverse of that is adding 5. And we're going to do that to both sides. So we end up with 4x we didn't even touch. This minus 5 plus 5, that ends up being a 0, and that equals to negative 33 plus 5, so I'm negative $33 in the hole, Mom gives me $5 because she sees that I'm negative $33 in the hole, but she's not that nice. She's not going to give me all the money. She's just going to give me $5. So I'm still negative $28 in the hole. I'm still overdrafting. That just sucks. So from here, I have 4x is equal to negative 28. 4 times x is equal to negative 28. So now to undo this 4 times x, I can do the inverse operation of dividing by x. I'm now showing you the division one instead of the fraction version. So 4 divided by 4, that ends up simplifying to just 1. So we have simply an x is equal to negative 28 divided by 4. Well, 28 divided by 4 is 7, and a negative 28 divided by 4 is going to be a negative 7. So in this case, we now have x is equal to negative 7. Let's check our work. We have 4x minus 5 is equal to negative 33. We said just now that x is equal to negative 7, so we're going to put that in for x. We have 4 times negative 7 minus 5 is equal to negative 33. 4 times a negative 7 equals negative 28 minus 5 is equal to negative 33. So now I have $28 in the hole. I decide to buy a t-shirt for $5. So I'm now $33 in the hole. So 33 is equal to 33 every time. So that checked out. So that's how we are going to be using the order of operations and our concept of inverse operations. So here we go. Here's our last problem. Here's a problem with, actually we have 2 more problems. This is a problem with negative coefficients. We have this situation here where we have negative 15 minus b is equal to 44. Well, let's think about negative 15 on a number line. If I'm looking at negative 15, I have 0 right here, and let's say we're going to go down by 5, so here's negative 15. There's negative 10, negative 5. So I have negative 15 down here on a number line. I want to figure out how do I need to get this negative 15 to become 0. How do I do that? How do I get negative 15 to become 0? Well, I can essentially add 15. That neutralizes that negative number, so I'm going to add 15. That is my inverse operation of that negative number. So I'm going to do that to both sides. I'm adding 15 to both sides. And negative 15 plus 15, we've already discussed that. That neutralizes everything to 0. So I still have negative b is equal to 44 plus 15. That ends up getting me 59. Ooh, big number. So I have negative b is equal to a positive 59. Negative b, this can be rewritten as this. Negative 1 times b. All right? There's a hidden negative 1 there. It's nice and invisible. So I'm going to rewrite this as negative 1 times b is equal to 59. So if I have a negative 1 times b, we are going to then essentially do our inverse operation. If we're multiplying a negative 1, I can divide by negative 1 to undo this. This gets undone. And I can divide by negative 1 on the other side. Remember, you have to do things on both sides. So we end up simply having a positive b is equal to negative 59 divided by negative 1, or 59 divided by negative 1. Now I know 59 divided by 1 would just get me simply 59. This time we have a negative included in here, and we know from our multiplication of negative, or a positive and negative number, there needs to be a negative somewhere in this situation. So negative 59 divided by negative 1 will get me a negative 59. So my answer is negative 59. We can check this work out, see if it works. So negative 15 minus a negative 59 is equal to 44. We can look at this subtracting a negative, and that can essentially say, oop, we're going to add little plus signs to this. So in all reality, we have negative 15 plus 59 is equal to 44. I'm negative $15 in the hole, and Grandma and Grandpa gave me 59 bucks. That was pretty sweet. So in all reality, I'm no longer $59 in the hole. I have a positive $44 in my bank account. So 44 is equal to 44 every time. So that's our second equation, or second situation. Last problem that we're going to do. We're going to combine some like terms before we actually do things. We have negative 9 times c plus 4 plus 3 times c is equal to 58. So we need to combine like terms. Like terms are situations where we have the same variable for a couple of different terms, and terms are being added and subtracted. So I have negative 9c and 3c. Those are my like terms. So I'm going to do this work off to the side. Negative 9c plus a positive 3c is equal to negative 6c. So now all of this is going to get me negative 6c plus 4 is equal to 58. Now we can just simply solve using inverse operations and working backwards. So our very first thing of working backwards, we're going to subtract 4 from both sides. Remember, we're going for addition and subtraction first, for our inverse operations. So we end up getting 0 right there is equal to 58 minus 4 is 54. And we still have our negative 6 times c. So now we need to undo our negative 6 multiplied by c, so we can divide by negative 6. I'm showing us the fraction version again. We can simplify this. A negative times or divided by a negative will get us a positive, and 6 divided by 6, that'll get us 1 every single time. So we have 1c is equal to 54 divided by negative 6, we get negative 9. So let's check our work. Let's see if this all makes sense. Let's put that back into this equation here. All right, so we have negative 9c plus 4 plus 3c is equal to 58. So we have negative 9 times negative 9 plus 4. Oops, I just messed up. Plus 4 plus 3c is equal to 58. Negative 9 times negative 9, let's do that first. Ooh, I should have added in right here, I should have added in that negative 9, multiplying that in there. Negative 9 times negative 9 is a positive 81 plus 4, and then this multiplication here we can do is negative 27 is equal to 58. I'm running out of room. So 81 plus 4 is 85 plus a negative 27 equals 58. You can do this on a calculator, but we can also do it in our head. We have essentially 85 minus 27, 5 minus 7. We can't do that, so we need to borrow. 15 minus 7 is 8. 7 minus 2 is 5, so we have 58 is equal to 58. Awesome. Checked out. So that is how we do inverse operations and do this with two-step equations. So play around with this concept with your next goal. Good luck.